Now, in this video, let's have a look at our second half of our new buoyancy system that we're also working on. So the previous video, we created this boat actor that worked with Gen 4 and Gen 3 oceans, but this time we're going to be looking at our more special actor, the Gen 4 baked. And the idea behind this actor is that it will be targeting multiplayer projects. Now, even upon release, this will still be a bit of a beta test, so just be wary that this might not quite work as expected, but in this video we're going to do a quick overview of what it does and how it works. So for starters, we have this level here all preset, and let's see what happens when we press play. Well, first of all, we have it set up in a multiplayer environment, and you could see that the motion of the boat is synced across all clients. And that is because the ocean right now is working in two modes. We have our regular GPU ocean simulation here driving the visuals, but for collisions, we have the same ocean running at a lower resolution entirely on the CPU. So let's have a look at how we could set this up. Now, this ocean, while baked, it's actually still quite dynamic. So right now, if we were just to disable this for easier visuals and hit play, we have rigged up a basic level sequencer over here that can drive things like, that can drive the scale of the ocean. So right now, if we were to lower this, we have smaller swells, and this isn't just a simple modification on the wave height. Wave shape, wave speed, and overall amplitude are all driven by this sort of change over here, from massive waves to small waves, and you could see the boat reacting accordingly to all of this. Now, if we were to exit this and go to our ocean actor, you will see that we have a bunch of new parameters for the baked ocean. We have speed, state, we can rotate it, and we can add panning speed and panning direction. Now, these are aimed to make our baked oceans a lot more dynamic, meaning you could almost match them with a full-on real-time FFT sim. But why use a baked ocean? Well, baked oceans are predictable, they're looping, and they're generally great for, well, multiplayer projects. Instead of using a more repeatable and tileable Gerstner waves, this is a more complex structure that provides a lot more visual fidelity, as you could see with the massive swells here, while still being quite cheap to run actually. So let's have a look at what's driving all of this. If we open our boat, from our previous video, you might remember our setup that required us to do a ocean actor and a ocean buoyancy solver. Well, in this case, we're using a different actor to reference, a dedicated blueprint flip buoyancy solver over here. And this, sure enough, is an actor on our map over here. Now, it's kind of set to being invisible by default. So let's just enable preview collision. And if we were to go into wireframe mode, and run preview, there we go. This is our ocean collision running on the CPU. Right now, it's not matched with the ocean speed because we're just kind of running a preview of the animation, but we have parameters here for ocean tile, wave height, speed, and state. State, as you can imagine, is what's driving the Beaufort scale. So if we go to 0, we could see, we need to override this. We can set this to 0, calmer, and 0.5 larger swells and larger swells. Now, because this is running at a much lower resolution to make performance all great and pretty much have zero impact, this is running at this scale. Now, ocean tile will again decide the density upon this mesh here, but something to note is that this new actor requires a new type of asset, which we're calling the buoyancy dataset. So let's see how we can transfer our baked ocean, which for the moment is basically this ocean texture, which is packed into the RGBA channels, into an ocean dataset. So for starters, we've made some big changes to the way our ocean baker works. And if we were to go into this map over here, Ocean Baker, demo levels, ocean capture map. We can see that the ocean is a little bit messed up, so we're just, because it's referencing some parameters from the previous map, so we're gonna hit live ocean and it's all going to be great. So we have our regular Ocean Baker over here, which you may recall from our previous videos. And right now we can capture the ocean. And sure enough, it's done its thing and we have a baked ocean simulation. Now, a couple of things to note, that when baking for this sort of purpose, we recommend having the capture length set to 16, and for the ocean simulation to be FFT based, but have the wave speed set to 1 over here. This will ensure that the ocean loops in a very sort of pleasant way and there is no any sort of inconsistencies in speed. Typically, this isn't too important, but very large swells, like we're looking towards the higher end of the Beaufort scale, move very slowly, and changing these settings can sort of impact the consistency of motion in those large swells. So now that we have an ocean spectrum that we're happy with, something that we would do is select our Ocean Baker. We're going to go to our final result, right click, create static texture, and be done with it. Next up, if we want to bake out a full ocean spectrum, well, it's actually quite simple. Open up our FFT simulation again, and once we're happy with all of our parameters here, we're just going to change the wind speed to something like 5. Now you can see our waves here became larger, and we're going to have our Ocean Baker capture the ocean again. Now you can see that it has done its job, and a new ocean has presented itself. Once again, we're going to go for the final result, right click, and create static texture. Now, once we have done this 4 times, we actually have this here under examples in baked spectrum. We can populate these 4 slots over here. Now, if we're going for a Beaufort scale where the waves grow along with wind speed, we would put the smallest wind speed of 2 in the alpha channel, wave 5, wind speed 5 in the red channel, 8 in the green, and our largest for the blue channel as so. There's a bit of a pack offset here that we recommend, just so the ocean height remains consistent when packing these. But overall, once these are done, we're happy to press the pack ocean button, and here we have a final result over here with all of these oceans baked into it. So what we need to do next is navigate to this asset, right click again, and create static texture. Now we already have the static texture over here, so now what we need to do is make it into a data asset. And this is where this other actor comes in. This is our Buoyancy Baker. And the buttons here are pretty obvious. What we need to do is basically drag and drop our texture here. Ocean state preview, preview height, and all of these are pretty much ways to preview if the actor has actually done something. And there's some adjustments here for debugging that you don't really need to mess with. We can run a preview, and you could see that the ocean state of 0 is now playing back. We shouldn't really worry too much about speed. Right now it's a little bit too fast, but this is something we can adjust later on. We can go for 0.25. You could see the second ocean is also stored, 0.75, and 1, the largest swells. Now this is a linear interpolation, so these will get blended across each other in a smooth manner as well. We can also pause the preview, whoops, and yeah, have all this good stuff available to us. Now let's go back to our vessel map. And run a little bit of our ocean. And one thing we very much recommend in this case is to also use our ocean time blueprint. It's just a simple actor that you drag and drop into the level. And what it does is it sets this particular parameter in this specific, material parameter collection asset. And Basically, everything ocean time related references this asset, from materials to ocean functions to simulations. So basically, supplying a consistent time in this here parameter will sync up time everywhere. So in this case, it's an easy way to sync up ocean time for something like clients in a multiplayer environment. You could use get real time in seconds or get server roll time in seconds. It's currently being driven by a timer and a function. We kind of have it set to multicast at the moment, and it's triggered upon begin play. Now, this is a bit of a setup that you can customize a bit further based on your project needs to reliably drive this particular parameter. But in most cases, that's pretty much all you need to worry about. Now, if we were to go into our baked boat, we have a similar setup of a multicast custom event that's also being run on a timer. We have these running at a slightly lower 30 FPS because we don't really need them to run at 60. It saves a bit of performance, and the overall motion of the objects is still pretty great. Except for the ocean time, we have this one set running at 60 just so it is more smooth. But again, this is something that you could customize to your liking. Moreover, the ocean solver is also set to run in a similar manner off a custom event that is being multicast, and it's running at 30 FPS as well. Again, this is something that you can adjust. The setup is pretty much the same as this across all of these actors, so it's something you could tweak as needed. And finally, this is pretty much it on the ocean time. To make sure that we're referencing this specific parameter for ocean time, we need to enable override time, and in editor this will pretty much pause it, but if we hit play, this will ensure that our flip B solver and our ocean are referencing the same time for the ocean that is on the CPU and on the GPU. And you could see our boat here being driven by the simulation. Now, a couple of other cool things that we could look at is, let's just disable override time so we could start messing with some of the new parameters over here. But you could see that baked ocean speed is, well, it's pretty much self-explanatory, but it can speed up or slow down the animation. Baked ocean state is what controls the scale of the massive waves. Let's set it to 1 so it's mostly visible to follow. And for baked ocean rotation, well, it's where these waves are facing. And these can be changed smoothly, although it's in degrees, so it might take a while at this rate. 300, and yeah, this will rotate him in a smooth manner so there isn't any horrible panning from world origin point. Then we have panning speed. You need to be careful with this as it can be quite fast. Let's see with something 5. And panning direction, as you could see, is independent from the ocean rotation. So it's another way to further customize things. And if we were to go back and set up override time, this will pause, run play, and see that our boat is still syncing up with the waves. Again, the waves may be moving a little bit too fast for the dampening of this boat, but overall, this is a great workflow that you can create a ton of details here. Something else in this particular setup that we have is run a second ocean simulation for all of these close-up waves over here. Now, we're running actually another baked ocean here, although if the need arises, we could do a full-on FFT simulation and have even more detail going on around the camera. And again, we have some pretty great tile break VFX here, so the ocean is not going to be tiling in a noticeable way. We also have our new detail generation system going on here, so we'll have great control over the poly counts. In fact, in this case, we've actually set it to be a bit lower scale. We can go with a greater level of density over here and really start getting even the smallest details. Although technically, if we're running the second cascade with a ocean tile of 250 at 512 resolution, you probably won't need all of these, and we can save up on a bunch of triangles like before. So overall, this is the new Ocean buoyancy system running in its full with a non-rigid body physics boat and an ocean collision that it's running on a CPU in parallel. Overall, just note that this is still a bit of an experimental feature, and the overall networked environment things are still a bit new to us. So this could have some potential drawbacks that we haven't seen or encountered yet. So use it with a little bit of caution. And yeah, other than that, go make awesome things.